For everyone, hello. I am your speaker right before lunch. My name is Daniel. I am still a PhD student. I told Jared that this conference is pretty much a running tally of how long I've been in grad school. So I'm an instructor, data scientist, a community member around the DC and New York areas. I'm also, in about a couple of weeks, going to be one of the interns for our studio. Yay. And also, like Jared said, wrote this thing in some other language that's not this conference. So in the DC area, I get a lot of flack for attending all these R meetings and then all of a sudden giving away a book about Python. So PyCon was last week, and so I wore my NYR shirt in front of the giant stadium just to make it fair, I guess. Something else that I did, so Hugo and I also started an R package during PyCon. I also, if anyone uses Ansible, submitted a pull request to Ansible to help build R packages in Ansible. So I was pretty productive doing R things at the Python conference last week. So, like Jared said, I just got my CAVE certification, so this is very recent, and I get to don on life support equipment and go into deep dark holes. And on the role of mental health, this is sort of one of the few things that I found that I can totally check out of the world. And so I am also working on being an instructor so I can help other people do other things to detach themselves from daily chaos. So this talk is really a continuation from the talk I gave around at DC a couple months ago. There's a link to it. But pretty much the problem that we were solving then is structuring your data science projects. Right? So we're happy when our code just runs. R gives us a bunch of tools to make this happen. So we saw from Emily's talk about how we can easily make packages. Jared showed about the here package to help finding paths easier. And if you really think about this problem, all the little problems you have when you're working with projects or analysis pipelines, a lot of people end up converging to the same exact problem or solution. So Jenny Bryan has a talk about this, or a book, a manual about this. John Blischek actually wrote an entire R package called Workflow R that pretty much sets up project templates for you guys. So people converge to the same solution. And my point back then, and it still holds true right now, is it doesn't matter where you are in your learning path. There's always some other thing to make life easier, right? And so at the end of the day, I just want stuff to run the first time around. I don't want to mess around with project paths. I just want to run my code and then be done with it. So this is sort of the summary from last time. There's different steps in your R journey. So the first step is, OK, this is an R conference, so we'll use R. And then if you have problems with working directory stuff, then add a project, right? Just layer up complexity until you get used to it, then go to the next layer. And then you'll end up with knitr and other things knitr doesn't really respect where my working directory is when I knit projects. What do I do with that? So we have this here function from the here package that comes from a library called rprojroot. And then that's great. We have our whole knitr document. But then you end up with this problem with sometimes your scripts are 500 lines long, or your documents are 1,000 lines long. And then you realize, OK, maybe I should break this up into multiple files, right? So the analysis thing is separate from the data cleaning thing, for example. And then what you want to do, this was something that got put into words better than I can by Rachel Tapman. She's one of the data science advocates at Kaggle in Seattle. And pretty much what you want to do is really use R Markdown for the thing that you want to show, right? There's no point putting an entire data cleaning pipeline in an R Markdown document. Just make it an R script. And then the R Markdown file should really just be, hey, here are my results, right? This is the thing you want to show up to the meeting. Emily showed how easily you can make an R package. So when you start making your analysis gets bigger, one of the key things in making an R package is put all your functions in the capital R folder. So if you start doing that in your analysis project, then what you really need is just that one description file that you can add anytime later on, and then your entire analysis can be installed as an R package, right? So it's just about adding little things just to set yourself up for the next piece. And then you can start using makefiles and shell scripts to just build everything in one go, right? So where did we originally start? There was a billboard data set and a script that had everything in it. So hopefully this works. So this is the example script that I had, right? I'm setting a working directory. Don't do this. And this is actually, if you go to the tidy data paper, this was Hadley's original code before dplyr, right? You can also see like there is no slicing notation. This goes from X to the 76, I think that's where that goes. Then we go through a step of tidying data sets, right? This is something that you would do. You might think about how your data is going to be stored, so there's a normalizations section. And you'll also notice that in RStudio, if you do this hash and then a word and then 5 dashes, it'll start creating sections that you can jump to in RStudio. And then we go through exploratory data analysis, so there's stuff there. And then at the end, we might fit a model. And then at the very end, we might ask some questions, right? And this is pretty simple, and it's already 170 lines, right? So when I say like break this thing up, I started this process of almost never using this section break in RStudio because most of the time that should just be a separate file. And I just write out files and read back files in and out that way. All right. So this talk is really about reproducibility and replicability. So reproducibility, if I'm going to define it, is the extent to which consistent results are obtained when the experiment is repeated versus the actual experiment being done again through another system, right? So like there's a difference between like, hey, I want this thing to run on my computer, and if I hit go again, it gives me the same result, versus, hey, I am giving you the process that I have, and I want you to rerun the experiment with your data and see if the results match, right? This is a common problem that we have in science. And so if I look at my project, here's like an example folder that we have. We have an analysis folder, and I have all of my scripts that somehow didn't get sorted. But you see that not everything's in our markdown file. The only thing in here is a model and my EDA, and everything's a regular R script. I have my make file to make everything. And then there's just a bunch of output that's either the report or like an image or something else. And then there's a folder called original under data. That is the data set that I got in, and I never change it because everything else goes into a folder called processed, right? And this way, like I can know if I delete everything in process, there's some system to just build everything back. So how do we run scripts from a command line? We can run R script, and then the name or path to the script that we want to run. And if you end up using here in rproj root, what's nice is if you, instead of just putting .. or just the name of the file in your R script, if you use here, because it's going to find the absolute path to your data set wherever you are, and it's based off the R project, you can like save yourself a lot of typing, and you don't have to type all of this. You could really just type go cd into the 01, the folder where 01 load R is, and just run it straight there, right? So it'll save you a lot of typing in that sense, because it'll find the working directory or find the correct file for you anyway. And then if you want to run something in the background, this is assuming you're on like a Unix, Linux system, you can no-hup the script, background it, so you can continue other parts. So the no-hup thing is pretty cool. If you're using RStudio 1.2, there's a new jobs panel in the top, in one of the corners. And that sort of lets you do the backgrounding straight in RStudio, so you don't have to like remember that weird terminal command. You can put in your R script here. You can even set your working directory. And then you can hit start, and then your job just runs. And the nice thing about that is when you're in RStudio, you'll remember if you hit like source or whatever, the entire session locks up. You can't just keep working again. And so that's why breaking up your scripts into different pieces is really useful, because you can just say, hey, this thing's going to run in the background and clean my data, and I can just work on the next portion of my script, and about you go. What about build scripts? So I have everything, and I just want to rerun my analysis. So this is where make comes in. So make has things called tasks. There is a target, followed by a colon, and then all of its dependencies that are separated by space. Make is really antiquated, and sometimes this part shows. There are different actions. So like this defines all the commands you need to do to make that target. And those actions, for example, like running an R script command, has to be a tab, not 4 spaces. Essentially, it has to be a \t. And then you just state which commands you want to run. So I know we're in our conference, but I'm really here to teach you make. And so you can make a really simple makefile. It supports variables, so billboards. Here I'm using defining all and commands, and all it's doing is looking for these 2 hashes. So when I say make, for example, it will print me what I state in these comments. So this is a self-documenting makefile. And so the easiest thing you can do is just say, hey, when I say make billboard EDA, just run my entire pipeline, right? So this is just going to run all of those scripts in that order, et cetera, et cetera. And I can also make like a clean file or a clean command, and it just deletes all of the files that I know that got generated. So if I want to like redo my analysis, I can just say make clean. Everything that I know that got generated is deleted, and then I can just rerun the entire pipeline again. So when I say break up your script into different parts, this is really what I mean. And like I do stuff like this when I'm documenting projects for work. I have a file, and then all of the inputs that go into that file. Right? So this is sort of like in one of the projects that I had at work, this was like a table in the README, right? So for each script, I listed all of the file inputs. And then as another column, and this is really in one table, but I can't show that on the screen, you also list what are the outputs for each file, right? So really what I'm doing is like for each script, I write out some file, and then in the next script, I read it back in. This can also be written to a database, whatever. But if we really think about it, so this is stuff I actually do when I start making makefiles, is like draw this out, right? Like don't rely on just staring at stuff on the screen, because drawing things out, like I just taught in the Git workshop yesterday, it really helps slow you down and like makes you think about what's going on. So I have all of my file inputs and the scripts to run each one of these. Right? And that comes in handy because sometimes certain inputs for a certain script generate multiple outputs. So the problem that we have is if I just run the entire pipeline and one of those steps takes like 30 minutes, if I run make pipeline, for example, it's always going to take at least 30 minutes, right? So sometimes if I edit the last file that prints like one simple plot, like there's no need to wait 30 minutes. And so that's what make is actually doing, is it's capturing this dependency tree and only has to rerun the portions that need to be run. And that's also why I started to break my code into pieces, because if this thing took 30 minutes, I do not want to accidentally rerun this code again unless I absolutely have to. So let's make our build script a little better. So we can add a few more variables that just helps us with the saving to all the various outputs that our script is going to go to. And we can make, here's the tidy section of our script, right? So I have all of these other scripts, and then this is all of the code that has to do with making the data tidy. You'll notice that in make, there's something called a phony variable. And so because a target has to be a file, when your target is not a file, you sort of make this a phony variable. And I'm pretty much saying that when I say tidy, these are all of the files that need to be checked to see if they're up to date when I say tidy. And then for each one of these files, for example, billboard, songs, and rank, they'll be listed to the left-hand side of this colon. And to the right-hand side, that's all of the inputs, right? So that's why when I said like draw everything out, is because you actually need to capture what are your inputs. Also, remember, you'll notice, for example, in this case, that the script that's used to generate the target is also an input, right? You don't want, like, just because your data changes, you rerun your targets. If your script updates too, or you make changes, you actually really want to rerun that pipeline as well. And then we can do the same thing for the EDA portion. So I'm making a phony variable called EDA. These are the two things, targets that relate to EDA. And the actual target is this EDA.html. It relies on the R Markdown file. And then to generate that HTML, I run this render command from the R Markdown package. And then I can do the same thing for model. So this model comes from this tidy CSV to generate this model.html. And you can sort of, I guess I didn't copy paste it. But then there's also the command to rebuild that that model target as well. And then if you want, you can just say, hey, every time I make EDA and model, I want them always run at the same time. So you can make another phony variable called reports that just links to the HTML for EDA and model. And then I can just make something that's like, let's just run the whole thing that's tidy and reports. And those targets are going to be for tidy and reports. And the whole point is, like, I can either say make reports or make tidy and reports, and I'll just build the whole thing, or only parts that need to get updated. Right? And then so what I will do in my command line is say make, point it to my make file. So this is called makefile2. I can clean it. So all of my output is deleted. And then if I want to run the entire analysis, I can say makefile tidy and reports. And then, for example, if I delete a file or change a file, it'll only update that last bit. Right? So I think we have enough time for me to show this. Uh-oh. Live coding. All right, so here is make clean, right? And then you'll see when I make clean, all of the folders in here, all of the files in there got deleted. And then I can say make tidy and reports. And you'll see, if you sort of squint your eyes, it's running through each one of those scripts. And then right now, it's running knitr for those two knitr documents. And it's creating those outputs. I believe if I start refreshing or looking in here, you'll see that those plots are being generated. All right, so let me go to output one more time in reports. So let's say I delete this file, the model HTML file, and I run tidy reports again. You'll see that the first thing that gets run is just some knitting function, right? So all of those other scripts, because they never changed, don't need to be run again. All right, so this is in our conference. There's this thing called Drake. Why am I not talking about Drake? Well, it is something just like make. If something doesn't need to be updated, it won't run. There's a manual here, and there's documentation here. You could potentially do what I just said in R. But it's not exactly like make. Drake has this notion of a plan, which is very similar to how make defines targets and dependencies and actions. So there is like a target, which is an R object. But the problem that I end up having is like the command has to be an expression, like an arc expression. So everything has to be a function. And so this is what a Drake plan looks like. This is taken from the documentation. You have something called raw data. That's just a variable. And you have this special Drake function called file_int. Right? And this is how Drake is building that dependency tree, right? Like just like how I drew out that thing, file_int is saying this is a file input. And this raw data is now the input for this mutate function, and it's called data. And then, data here is now the input for the next piece, which is called hist. And all of that eventually feeds into this knitr report. And because data frames are such a fundamental piece of the R language, you get a Drake plan that's really a data frame that you can kind of analyze that tells you for a given target, this is the expression. That's great. But that doesn't really work with if you break up your code into individual scripts. For example, if I'm just saying source this file, source this file, source that file, the problem is there's no way to link what the inputs are. Right? So that's the problem I'm having when I work with Drake. Everything has to be sort of an R function. And all of this stuff really has to like be loaded in memory, and there's temporary output files that get placed in your directory. So I can't personally use this. If I really wanted to, I'd have to rewrite all my scripts. I can patch my scripts by wrapping everything in a function, sort of defining inputs that way to make this work with Drake. But I'm not here to complain. As other open source maintainers will know, complaining isn't really helpful. So during the summer, I'm working on this project called Grade R that really tries to automatically grade students' code. So given a piece of solution code and some piece of code that you're submitting, not to just be like, hey, your answer is wrong, but try to figure out like why your answer is wrong. Like maybe you should have used gather instead of spread, for example. And the reason for that, well, how does that fit into Drake? Well, so I really want to say, given a script, find me like the file inputs and file outputs, right? So that'll be one step to making Drake a little bit closer to how I work by extracting those automatically, and it's more than just string extraction. And essentially, I know my time's up, but the way I plan on doing this is looking at something that Hadley talked about last year called abstract syntax trees, where you can just break up a function call into its individual components, and that's how I plan on finding your file inputs, and hopefully we can find input-outputs of files, and then fold that eventually into Drake. So Will, I'm sorry, I know I'm complaining, but hopefully I'm doing something about it, and that's my talk.